Control requires knowing what causes the outcome. Correlation tells you that two variables move together. Causation tells you that changing one will change the other. Only intervention on the true cause produces the intended effect. Intervening on a correlated variable that is not the cause does nothing. The outcome is determined by its causal structure, not by what co-varies with it. Control without a causal model is guessing. A structural equation model assigns each variable a mechanism. Each variable is determined by its causal parents and an independent noise term. The equations encode mechanisms, not statistical associations. When you intervene, you replace the structural equation for one variable. You set that variable externally, severing its connection to its parents. The rest of the model is unchanged. This is how intervention differs from conditioning. Identification asks whether the causal effect can be computed from observed data. Even without running an experiment, it may be possible to recover the interventional distribution. This requires that all paths through which confounders influence the outcome can be blocked by conditioning. When such a blocking set exists, the causal effect is identifiable. The calculation uses only the observed distribution. Identification is not always possible. It depends on the causal graph structure and which variables are observed. A hidden confounder is a variable that affects both the input and the output but is not observed. Because it is unobserved, it cannot be conditioned on. The backdoor path it creates cannot be blocked. In this case, the causal effect cannot be recovered from observational data alone. No statistical technique removes a bias from a variable that was never measured. The only solution is to run a controlled experiment where the input is assigned externally. Without that, the causal effect remains opaque. Intervening on a variable that is correlated with the outcome but does not cause it changes nothing. The variable you set has no path to the outcome. Setting it to any value leaves the outcome distribution unchanged. This is the fundamental failure mode of policy based on correlations alone. A target indicator can change without the underlying outcome changing, because the indicator is not the cause. Causation, not correlation, determines what control can achieve. When the process has no remaining distance from the failure boundary, causal structure becomes irrelevant. No intervention can restore slack that no longer exists. The structural conditions for control have already been eliminated. Control theory assumes the process is in the interior of the feasible set. At the boundary, that assumption fails. The causal mechanism may still be present, but the path through which it could produce a different outcome has been closed. Effective control requires three conditions simultaneously: a correct causal model identifying the true cause, a causal effect that is identifiable from available data, and structural slack, sufficient distance from the absorbing boundary. If any one of these conditions fails, control fails. Correlation-based intervention fails the first condition. Hidden confounders fail the second. Zero slack fails the third. The conditions are not redundant. Each one is separately necessary.